A particle is moving with acceleration a of t, 12t plus 4. Its position at time t equals 0 is s of 0 is 17, and its velocity at time t equals 0 is v of 0 is 4. What is its position at time t equals 9? Okay. Well, first off, we got another relationship between these. So I'll put it over here. So S, which is what we always use for position. I don't know why we use S for position, but V is velocity and A is acceleration. So these are by derivative. So if you take the derivative of position, you get velocity, and the derivative of velocity, you get acceleration. So then vice versa, if you take the antiderivative of acceleration, you get velocity, and the antiderivative of velocity, you go back to position. So we're starting with acceleration. We've got acceleration at any time t is 12t plus 4. And then so what we're going to do then is the antiderivative, and that'll turn it into velocity. Okay, so how do we do antiderivatives? You remember x to the n, the antiderivative, it's the opposite of the derivative. So you add 1 to the power instead of subtracting 1, and you divide by that number in the front instead of multiply. Okay, and so this is a 1 power. So I'm going to add 1, so bring the 12 down, add 1, that'll become t squared, and then divide by that number. Plus, now, this one I'm just going to think out, what could I put here? And the derivative, right, because we're doing anti, so this was anti, and this is anti. So vice versa, it's derivative. So this is going to be 4t. That makes sense because 4t, the derivative will go back to 4. So 4t must be the antiderivative. Plus constant number 1. There's always a constant. Why? Because the derivative of that would go back to 0. It would be nothing. So there could be a constant there. Constant number that doesn't have t, just a number without any letter. Okay, now how do we find that constant? Well, they tell us right here. The velocity at 0 is 4. So if I plug in 0 at time 0, this is going to be 0. It's going to be 0, constant 1, and that's equal to 4. The velocity at time 0 is 4. So the constant 1 is 4. So then we've got the v of t equation. 12 over 2, that's 6t squared, plus 4t, plus constant 1, which is 4. Right there. All right, we got the velocity equation. Now, we want to take another step back, another anti-step to the position equation, right? We're going up this way. We started with acceleration. We did an antiderivative to velocity. Now we're doing an antiderivative to position. And then we'll do the constant. So what's it going to be anti? So that you got to add 1 to the power, bring the 6 down, add 1 to the power, and then divide by that number, the opposite of the derivative. Plus, bring the 4 down, that's a 1 power, add 1 to the power, t squared, and then divide by that number. Plus, and this has got to be 4t, right? Because the derivative of 4t will go back to 4. Right? I'm doing anti here. This is anti, anti. And this too is anti because the other way, the derivative would go back. Derivative 4t bt. Now plus constant 2. There's got to be another constant because why? Because the derivative of that would go back to nothing. So it's any constant number could be out there. Any number that doesn't have a t. So now they tell me s of 0 is 17. So that means if I plug in 0, I'm going to get 0, 0, 0, plus constant 2, and it's 17. So constant 2 must be 17. So now I've got the position equation complete. 6 over 3, that's 2t cubed, plus 4 over 2, that's 2t squared, plus 4t, plus constant 2, which I now know is 17. So I've got the position equation. That's an important step. Now I can answer the final question. What is the position at time 9? So plug in a 9. So I'm going to position at 9 seconds. What's the position of this object at 9 seconds? Right, these are seconds, I'm assuming. It doesn't even say, it just says time 9. All right, let's go to Desmos. 2 times 9 cubed. So to Desmos we go. We'll go 2 times 9 cubed. 2 to the third. 2, what is it? 2 times 9 cubed plus 2 times 9 squared. Squared plus 4 times 9. Plus 2 times 9 squared plus 4 times 9 plus 17. Plus 17. There we go. 1673. 1673. Hopefully that was the answer. Yes, indeed. So there we go. We walked it backwards.